Okay, good evening, morning, everyone, and this is lecture 3. Lecture 3 Loop analysis. Loop analysis. In the last lecture, we discussed mathematical tools. So now we're looking at how do you actually analyze loops based on their worst, average, best case, and things like that. So first of all, we start with basic rules. Basic rules. So we're using programs here. What I want you to know, first of all, rule 1. Rule 1 states that the time complexity of a function is considered a 1 if it doesn't have any loop, any recursion, or any call. Okay? Any function or any program that doesn't have a loop, a recursion, or a function call is of order 1. Meaning all it has, like here, this is an assignment statement, an assignment statement, an assignment statement. So this entire statement is of order 1. This one too also. In this equation, or in this stuff, even though it was a for loop, remember what I said, that if it doesn't have a loop, recursion, or call, is order 1. But even if it's a for loop, as long as we know how many times it's going to run, it is also order 1. Assuming this was less than n, then it would have been order n, but this is less than c. C is a constant, so we know how long it's going to run. Okay, so rule 1 for order 1 statement, that is, it doesn't have a loop, it doesn't have a recursion, or it doesn't have a function call, and even if it has a loop, the loop runs a constant time c. Okay, so now the second rule is order n. Okay, the second rule is order n, order n, order n, and that just states basically that the time complexity of a loop is order n if the loop variable is incremented or decremented by a constant amount. Okay, if it is incremented or decremented by a constant amount. What is it saying here? For instance, this loop is I less than n, I plus or equals to c. So because of this n, the function of this equation is going to be order n. So also this, even though it's minus, the function is going to be order n. Okay, okay, so the third one now, the third one, sorry, I said the second one we're talking about was of order n. The third one now is of order n raised to power c. And so that is saying time complexity of nested loops is equal to the number of times it's executed. So basically, based on the number of nested loops, here there are 2 loops, so it's of order n squared. There are 2 loops, so it's of order n squared. So this, both of them are of order n squared. Assuming there were 3 loops, it would have been of order n cubed. So that's the third row. Remember, this one, the first one, has no function call, no recursion, no loop. Even if it has a loop, the loop is iterated a constant time c, not n times. The second one is when there's a loop, incremented or decremented n times. The third one, n raised to power c, is based on the number of loops. Okay, so for instance, it said that selection sort and insertion sort have n square time complexity. Why? Because this is the first for loop, this is the second for loop. So without much analysis, just by looking at this entire statement, you can see that there's a loop here, there's a loop here, so obviously it's going to be of order n squared. Okay, same thing, this is insertion sort, this is the first loop, the for loop, and this is the second loop, the while loop. So obviously all of this is going to be of order n squared. Alright, so the fourth rule we're looking at now is going to be order log n, order log n. So this was based on number of loops. Now order log n is when the loop variable is divided or multiplied. when it was n, it was incremented, that is added or subtracted from. Now it is log n because it's divided or multiplied by a constant amount. And we see that here for int I equals to 1, I is less than or equals to n, I times I times equals to c, that is I is equal to I times c. Here divided, so the order of this would be log n. The order of this would be log n. And it said that binary search has log n time complexity. Why? Because you look for the loop. We look for the loop and said if this, return binary search, else we do this. Okay, so this is what is being called the mid. The middle divides the inputs into two, and the recursion call calls mid. So in a recursion call in a loop is going to be of order n. So in our function call here, what is it actually calling? It's calling mid minus 1. What is our mid? R over 2. So it's dividing it, and we said here that when it's divided or multiplied, that's why it's going to be of order log n. So it's not just applicable to loops, recursions are also included. So now log n. Log n is if the loop variable is reduced or increased exponentially, that is raised to power or root. So maybe square root or cube root is going to be log n, or raised to power 2 or raised to power 3 is log n. For instance, here it is going to be I raised to power c, so that is log n. Here also is calling function I, and function I is square root, so it's going to be log n. That is our fifth condition, order log n. Okay, so now how do you combine time complexities? All right, how do you combine time complexities? Now I would like to state something here. In combining complexities, if they are on the same line, that is, they are on the same statement line, you simply add their orders. We'll go further. So general rules. The first one, the running time of a typical read, write or assignment statement is order 1. Okay. The second one, the running time of a sequence of statements is calculated using the sum rule. That's what I said here, you add. So for instance, you can add order 1 plus order n. Adding, you definitely just choose the bigger value, that's order n. The third rule here says that the running time of an if statement is the time cost of executing the conditionally executed statement plus the cost of evaluating the condition, because evaluating the condition is taken as order 1. Okay, so what this is saying here is that in an if statement, to find the order or the running time of that if statement, you find the order of the if statement plus the order of what gets executed if that if statement is true. Now what they said here is typically the cost of evaluating the if statement is always order 1. So it depends on what is actually inside the if statement. Now in an if else statement, so if so do this, do all of this, else do this. What it says is that you find the running time of both conditions, then you pick the larger one. So for instance, if this was true and it was order n, and this was, or if this is true and it's order n square, you pick the else statement that is order n square and add it to the original if statement, which is what? Order 1. Remember, the cost of evaluating an if statement is order 1. Then you add it to the cost of evaluating what is inside. So in an if else statement, you choose the larger condition and add it. So this whole if statement is of order n square. Okay, now the fourth condition says that for a loop, the running time is the sum of times taken to execute the body of the loop and the time taken to evaluate for termination. Okay, So in a loop, what you do is that you multiply. Okay, you multiply. We'll see that in the statement. Now, for a program that has functions that are not recursive, we combine the number of times of the called procedures. This is talking about recursive procedures. We'll discuss this in the next lecture. Recurrence relations. So now let's analyze the selection sort. We'll analyze the selection sort right now. Okay. So in the selection sort, from here, looking at it from a rough angle, we can see that there are two for loops here and here. So we can already safely say that this is of order n square. But meanwhile, let's just look at it to analyze an algorithm. If this question comes out in exam, you analyze step by step, usually from the base or from the innermost. So how to analyze how to answer this question? You say line 7 is simply an assignment statement. So you say line 7 is order 1. Line 6 is also an assignment statement. So line 6 is order 1. Line 5 is an assignment statement. So line 5 is order 1. We can combine them. So therefore, line 5, 6, 7. Remember what we said about a sequence of statements you add. So you find that is O max, the largest value of order 1, and order 1. Okay, so what is the largest order here? Order 1. So line 5, 6, 7 is order 1. Okay, so now let's move into, we've cleared this, let's move into line 4. Alright, line 4 is of what? Order 1. It's an if statement, and this is the if statement. The if statement is if ai is less than a min. What is the execution? Min is equal to I. Remember what we said about if statements? This is obviously order 1, but we look at what is inside and we see that this is actually also order 1. It's simple assignment. So this if statement is what? Order 1 plus order 1. That is the order of the if statement. Sorry, the order of the if statement plus the order of what is inside, and that's order 1. So we can say that line 4 is of order 1. Alright, line 4 is of order 1. Now line 3 is a loop, and it runs from j plus 1 to n. What does that mean? That the loop is of what? Order n, or order n minus j times. You can say it's of order n. Now remember what I said. For an if statement, you add the cost of the if condition, that is of order 1, plus whatever is inside the body. For a loop, you add the cost of evaluating the loop times what is in the body. Okay, so in line 3, the loop is of order n. The body was line 4, and that was, we've already established that to be order 1. So it's going to be order n times order 1. And what would that give you? Order n. So line 3 is of order n. So we can combine them now. We've already said line 5 to 7 is of order 1. Line 3 to 4 is of order what? N. So line 3 to 7, we're combining a sequence of statements. It's going to be order max, order n, and order 1. Which one is bigger? Another 1 is going to be order n. So line 3 to 7 is of what? Order n. Line 2 is definitely of order 1. Okay, line 2 is order 1. Now line 1 is also a for loop. So how many times is it executing? From I till n minus 1. Alright, from I to n minus 1. So we can say that line 1 is of order n. Line 1 is of order n. Okay, so now combining them, remember that, look at this, I want you to take note of this. This is begin, this is end. All of this is inside this for loop in line 1. What do we establish as a rule? For for loop, you multiply the order of the loop, of the for loop statement, times the body. What is our order of the loop? From line 1 we figured out that it was order n. What is the order of the body? That's from line 2 to 7. We've established that is of order n. So that is order n times n. What would that give you? Order n square. So from here you can see that the selection sort is of order n square. So to answer the question, you analyze each line, most preferably from the bottom. But before you enter, be careful of if statements and for statements, because if statements you add the execution plus the if body. For the if statement, for loops you multiply the for loop times the body. Okay, so look at our second example. I believe this is our second and last example, and that's the insertion sort. Okay, so the insertion sort, we start again. Line 7 is a simple assignment. Is of what? Order 1. Okay. Line 3 is of order 1. Now you look at line 5 and 6, and we see that it is inside a while loop. Okay, so before you start analyzing an algorithm, look through the whole algorithm from line 1 till the end. Try to understand what the algorithm is actually doing. So we see line 5 and 6 is inside a loop. What is line 5? What is line 6? Sorry, line 6 is order 1. What is line 5? Line 5 is order 1. We do not add 5, 6 and 7 because 7 is outside that loop body. So we add line 5 and 6. Line 5 to 6 would be order max, order 1 and order 1. And line 5 to 6 is of what? Order 1. Okay, so the for loop in line 4, or the while loop, is also a loop. What is it going to be? We can see that while j is greater than 0, and while that is less equals to 10. So now you don't see any n, but what is actually the true running time? Temp is ai, and we see that I is from 2 to n, which is why it's very important that you look through the whole algorithm before starting. We can see that I is 2 to n throughout the whole application. So j being I minus 1 is also, in a way, you can say 2 minus n minus 1, that is 1 minus n. So j is also running n time, meaning the while loop in line 4 is running n time. So how do I calculate 4, 5 and 6? Remember, it's a loop, you multiply. It will be order n times order 1, and that's what? Order n. So line 4, 5 and 6 is of what? Order n. Meaning line 4, 5, 6, 7, you add them, is of what? Order n. Okay, I hope we are following. Line 3 is of order 1, it's a simple assignment. Line 2 is of order 1, it's a simple assignment. Meaning line 2 to 7 is the max. Line 2 to 7 is the max, and that is still order n. Order n minus 1 is the same thing as order n. Now we check line 1, just like selection sort. Line 1 is of order n. And what is inside the body? Line 2 to 7 is of what? Order n. So line 1 to 7 will now be what? Remembering it's a loop, it should be order n times n, that is order n square. Okay, so I hope we are clear with this. You start from the beginning, from the base, and don't just cross into loops or into if statements. Make sure that you analyze a loop separately before adding it to the rest. So in the exam, when exam comes, it's very important that you would have checked the algorithms of the insertion, selection, shell, quick sort, heap sort, and merge sort. Just familiarize yourself with the algorithms. Then make sure you remember their running time, and if possible, how to analyze it. If possible, how to analyze it. Thank you very much. They said, how do you calculate time complexity of recursive functions? That is going to be the next lecture. Recursive recurrence relations. How to analyze recursive functions. So in this lecture, just to review, we looked at the rules. How do you know when an algorithm is of order 1? How do you know when it's order n? How do you know when it's n raised to power c? How do you know when it's log n? How do you know when it's log n? Okay, so also we looked at some rules. If it's a sequence of statements, you find the maximum. If it's a simple assignment statement, is order 1. If it's a loop, you multiply the body by the cost of the loop. If it's an if statement, you add the body to the cost of the if statement, which is usually order 1. So we analyze the selection sort and insertion sort. Thank you very much. Have a great time reading.
Man.